On this video, we're going to look at factors, looking at prime factorization, greatest common factor, least common multiple. And then we're going to look at fractions, how to simplify them, looking at how to do operations with fractions, so add, subtract, multiply, divide. Then we'll look at unit rates, where we're going to talk about ratios, and we're also going to look at percentages. So let's go ahead and get started looking at factors, talking about what are factors. So factors are just small numbers that go into larger numbers. So if we think small, 2 times 3 are factors of 6. You could get bigger. You could say 10 and 12 are factors of 120. Those are factors. Okay, we're going to look at 3 different things as we're talking about factors. We're going to look at prime factorization. And we're going to look at least common multiples, and then we're going to look at greatest common factors. So let's take a look at prime factorization. So prime factorization, it's the act of breaking down a number into its prime components, right? And remember that a prime number is divisible only by 1 and itself, right? So if we think of prime numbers, if usually it's 1, 2, 3, 5, 7, 11, 13. Those are the beginning ones, and prime factors go on up. Okay, so the most common way to represent prime factors is by a factor tree, which you can see here. I started with 42, and then for me, the easiest thing to do when I'm trying to think of prime factors is just start dividing by 2. Just start, if possible, divide by 2 or do it in half. So I get 2 and 21. Well, 21 I can't divide in half anymore, but I know that 21 is 3 and 7. So 2, 3, and 7 are the prime factors of 42. And usually we then can write it condensed as 2 times 3 times 7. So that is prime factorization. Prime factorization is really going to help you, especially given that there is part of the end of course exam that is without a calculator. So knowing your prime factorization will help you, especially with division. Okay, so let's look at these factor trees. Okay, let's work through these. So let's start with 144. Okay, so 144, there's 2 ways to do it. You can start dividing by 2 if you want, or you can recognize that 144 is 12 squared. I'm going to go ahead and do it as 2. So I know it's 2, and then half of 44 is 22. So that's going to be 72. And then I'm going to do by 2 again, and I'm going to get 36. Do it again. I'm going to get 2 and 18. Do it again, 2 and 9. And then 9 is 3 and 3. So my prime factors are what's going to be at the bottom of my tree. Now that's the way I do it. Most factor trees, you will also see these brought down so they line up. So they're like this. Okay. But we also need to get used to writing it simplified. So if we think how many do we have? So we have 1, 2, 3, 4 2's. So we can write that as 2 to the 4th. And we have 2 3's. So we can multiply that as 3 squared. So 2 to the 4th, 3 squared is the prime factorization of 144. Okay, so let's look at our next one. So our next one is going to be 1296. So if we look at 1296, so again, just going to start with 2. So I've got 2 And so the way I do it is I look at each individual thing when I'm doing it by hand. So I've got half of 6 is 3, half of 90 is 45, half of 200 is 100, half of 1,000 is 500. So 648. Okay. Do it again. 2. So then I've got 324. Okay. Can do it again. We get 2. Half of 300 is 150. 10 and 2. So 162. Okay. We can go again. Is 2 and 81. 2 and 81. 81, hopefully you recognize as 9 and 9, which is 3, 3, 3, and 3. Okay. So there's your prime factors of that. So we have 1, 2, 3, 4 twos. So 2 to the 4th. Then we have 4 threes. Okay. If you notice, it's very similar to 144. And if we look, if we take out this factor of 9, we're left with 2 to the 4th 3 squared. So at the very beginning, we could have done 1296 divided by 9 and been left with 144 and already had it prime factored. Okay, so as you're working through a test, keep that stuff in mind. That's why it's helpful to keep your work organized. So if you've already done the work, you don't have to go back and do it again. So let's go ahead and put this over here is 2 to the 4th, 3 to the 4th. Okay, and let's look at 33 last but not least. Okay, well, we can't divide it by 2, but it probably has a factor of 3. It's 3 and 11, and those are both prime. So that's 3 times 11. Okay, so that's how to make a factor tree. Okay, couple tips and tricks for factor trees and for prime factorization in general. Okay, if it ends in an even number, generally speaking, you can always divide by 2. You can always do it in half. If it ends in a 0 or a 5, it's going to have a multiple of 5, so you can do that. The other one is if the last one is if the sum of the digits is divisible by 3, then the number is divisible by 3. So let's go back and look at 1296. So if we take 1296 and we add 1 plus 2 plus 9 plus 6, we're going to get 18. So is 18 divisible by 3? It is, but if you don't know that, you can then add 1 and 8 to get 9, and 9 hopefully you know for sure is divisible by 3. So that tells us that 1296 has a multiple of 3 in it, and we saw on the previous page that indeed it does. Okay, so use these tips and tricks and try these 4. Pause the video here and try these 4 in your notes. If you have any questions, make sure you bring them to class. Okay, next thing we're going to look at is the greatest common factor. Okay, so our greatest common factor is the largest factor that divides into the two numbers, right? We're used to doing this when it comes to reducing fractions, making things smaller. So if we start at 50 and 60, so we can do, because it ends in a 0, I'm going to start with 5. I get 5 and 10. 10, I get 5 and 2. Okay, let's do 60. Ends in a 0, so I'm going to start with 5. So I get 5 and 12. 12 is 3 and 4. 4 is 2 and 2. Okay, so you're going to look for your greatest common factor. And the way I did it, it's a little hard to see. So you would think it's 5, right? But there's also this 2 down here, and this one has a 2. So we could write those together. So let me do 60 a little differently so you can see this. Instead of doing the 5, what if we did 6 and 10? Right, so the greatest common factor is going to be 10. So try these other two and see what you can come up with. Go ahead, pause the video here, and when you're ready to move on, press play. Okay, now we've looked at greatest common factor, which is which is used to simplify. Now we're going to look at least common multiple, which generally we used in getting common denominators. So we're generally getting bigger, not always. So the least common multiple, a couple things to note. Multiple cannot be smaller than your starting numbers. Right, so if we look at our first example of 12 and 36, right, 12 and 36, we know they both have factors of 6, so you might be inclined to say 6. But the least common multiple, LCM, can't be smaller than where we started. Okay, so if we think of 12 and 36, well, can we multiply 12 by anything to get to 36? And we can. So our least common multiple of 12 and 36 is actually 36. Okay. So if we look at the next one, the least common multiple of 18 and 5. So what you do is you can start 18 and then just multiply 18 by 2 and get 36 and keep going up until you get to something that has a factor of 5. The shortcut to that is if you just multiply 18 and 5, which you get 90. Okay. And more often than not, that is going to give you the least common multiple. Okay. And then we can do the same for 6 and 25, and we get 125. So I'll show you that process. So if we do 6, 12, now I'll do it with 18 and 5. So it's 18, 36, 54, I think. 72, and then 90. Well, when I get to 90, it ends in a 0, so I know it has to have a multiple of 5. So then I know 90 is my least common multiple. So once you get outside Algebra 1, you'll be able to use calculators that will actually compute least common multiple and greatest common factor for you. Okay, we're going to practice this in class. So for your homework, you still have Khan Academy arithmetic to do. Once we're done with arithmetic, we're going to switch over to working in ALEX. It'll be the last of the Khan Academy you have to do. If you have any questions, please bring them to class and we'll talk about it.